Welcome to the cross-site scripting room. We're White Hat Security. We're going to be presenting on hacking intranets from the inside, from the outside. This is going to be a pretty fun presentation here. Lots of demos. We're going to try to stay away from our slides as much as possible and stick to lots and lots of demos since they're more fun, but they're also very scary to do for the presenters. So we'll see what we get to. So just a bit about ourselves here. We're from White Hat Security. We run a managed service where we constantly hack the websites of our customers to let them know where the vulnerabilities are so they can fix them before the bad guys exploit them. Myself, most of the time I'm doing technology R&D, industry evangelism, speaking at conferences such as Black Hat, and this is my 12th time here. It's great to be here for such a big audience actually, but we also get to speak at ISSA and other events and things like that. And when I'm not doing cross-site scripting during the day of my day job, I'm doing it my night job with the Web Application Security Consortium. If you haven't heard of this organization, it's at webappsec.org. It has lots of useful information there and nothing but Web AppSec people to ask questions with and learn from. And which is why we're all here, to learn what the cutting edge stuff is so we can move things forward and hopefully protect ourselves. And prior to founding White Hat Security, I was also an information security officer at Yahoo. My entire job there was Web Application Security. And again, did nothing but hack websites, 600 or so of them, and 17,000 publicly facing servers. So I know lots and lots about web apps, but if you ask me to configure your Cisco PICs or anything like that, I probably can't. So anything out of the browser, I'm pretty good at. Anything else, not so good. And I brought with me TC Nijakovsky here. He's one of our senior security engineers who does lots of the hacking. And I'll let him tell you a little bit about his day job. So go ahead.
Like Jer said, I get to hack web applications, hundreds of web applications. Banking, finance, e-commerce, social networking, education, fun stuff. I can do that. It's awesome. Also, I get to try new attack methods, stuff that Jer and others are researching, and I get to use them against hundreds of production websites and see what the effects are.
So, again, Black Hat is a great opportunity for us to present. It's really the only show that we're aware of that allows us to show off the most sophisticated attacks with an audience that might appreciate that, what we're doing here. And this presentation here is really an extension off our last year's presentation that we entitled Phishing with Superbait, but this takes the act of cross-site scripting and JavaScript malware a lot further, so you're going to see lots of information there. And before when we were doing the cross-site scripting talks, we made everybody afraid to click on links in their email. Now we're going to make everybody afraid to surf the web. so let's begin and see where we are at. Again, we're talking about intranet security. And when you're doing intranet security, we make the following assumptions that, things on the inside of the perimeter that are behind firewalls, we can treat them differently than the things on the external perimeter, public web servers, public mail servers, and things like this. And we find on on just about everybody's internal network that they leave the hosts unpatched. They leave default passwords on. And they don't put a firewall in front of these devices because the firewall's at the perimeter. So all these devices are certainly not as secure as their publicly available cousins. And so that's what we have here, is more of an insecure environment. But these are assumptions that all this stuff is more or less okay because the perimeter firewalls are protecting us. We're here to tell you that this assumption is wrong. Okay, we're going to show you how JavaScript malware and using nothing but your browser can wreak havoc on the intranet. So we're going to see what we get to there. When we look at web-enabled devices, what has the web become, and what has HTTP been used for? It wasn't so much 10 years ago, but now every device, every business process, everything has a web-enabled interface. Everything from the DSL routers, firewalls, IP phones, what else? The little quick cams there, printers, and everything else. Everything has a web-enabled interface. And I was at a dinner with somebody last night. They informed us that their power supply system, the ones that with power supplies, you can connect to it via web-based interface for their UPS system. So that was different. So everything has a web-enabled interface, and where does that leave us? Are these things assessed? Are they secure? And even if they are, how secure are they really? So what is it we're talking about here? How do we breach this perimeter? Okay, how do we get inside the intranet? So when we say JavaScript malware, what is this? So intranet users, we're going to use the intranet user on the inside of the firewall to our advantage. To access the intranet, through the perimeter firewall. And normally the perimeter firewall here, as we all know, are set up where they only allow connections, you know, for no trusted ports, the good ports like 80 and 443. But everything else like FTP, SSH from the outside, NetBIOS, is blocked at the perimeter firewall. We can't connect to the intranet on the wikis, the printers, you know, the IP phones and all that other good stuff. But what happens here is the user, any user on the corporate intranet, when they go to a publicly facing website, they download that web page with embedded JavaScript code, Flash code, ActiveX code. That code is actually brought back into the enterprise, where now it can reach the intranet. So we're taking this stuff that we're calling JavaScript malware, because that's really what it's most indicative of, most close example, and that's now going to be running on the user's browser on the inside. So all this research is based upon what can we get JavaScript to do. Okay? So again, so a lot of this stuff will be really new, especially cross-site scripting, all the malware stuff. If anybody has any questions, please raise your hand, and I'll do my best to address the question. All right, so JavaScript malware, I said this term a few times. This stuff gets behind the firewall to attack the intranet. All the hacks you'll see here are operating system and browser independent. We make no claims that one browser is more secure than the other. And we want to thank RSnake. He's a fellow researcher that has helped us a lot with these hacks and allows us to bounce ideas off of them. So again, all these exploits you're going to see do not use any well-known or any unpatched browser vulnerabilities. This is native JavaScript in every major browser, Mozilla, Firefox, IE. We think Opera, though we haven't tested thoroughly. All the exploit code uses JavaScript, CSS, applets, and things like that. Just the normal, basic, everyday stuff. And on your CDs, we put all the exploit code, all our JavaScript exploit code, the proof of concept stuff on your CD, so you can run through all that stuff, so you can see how it all works. So that's what we have here. So again, no browser exploits. There's guys in other talks that are doing those, but ours are just native to the browser. So how do you contract JavaScript malware? There's several ways to do it when you're surfing the web. One is when you find your way to a website that might have JavaScript malware on it, the website owner might have put it there purposely, to embed it in his own website to ensnare users. So that's why you get the recommendation: you don't surf to potentially malicious websites. Another way to do it is that a person's website, a trusted website, a popular website, might have been defaced, and there's defacements happening, maybe hundreds, if not thousands, every day. So JavaScript malware might have been put inside of a defacement, and it has happened in the past. Another way to do it is through two forms of cross-site scripting. The first one, it might be injected into a public area of a website. We call it persistent cross-site scripting, where a malicious user would post JavaScript or some malicious code to the web page where other public users will see it. If any community-oriented user gets onto the website, it executes in the context of the security of that website. So that's one way. And the last way is a link. Again, another cross-site scripting vulnerability where we'll make a specially crafted link. We'll go over through several examples on how to do this, where you click on the link, data goes into the website, echoes back out, and executes within the browser. So there's four main ways. So we're going to, like I said, we're not going to do much of the slides here. We're going to go straight into the demos here. And if you want to go back to the slides, a lot of the slides will mimic our examples here, and they'll play off each other. So we're going to take about 2 seconds here to switch laptops from the slides to the demo machines. Okay. Oh, great. Okay. All right, this page here, we're going to show some basic cross-site scripting stuff, and we're just going to go right into it. So let me just ask the question to kind of gauge the audience. Who here has heard of cross-site scripting or knows what it is? Show of hands. Holy cow, okay. Last year it was like 4 people, and I think we were 2 of them. Okay. What we're looking for when we find a cross-site scripting vulnerability is a place in the website where we put in some user-supplied content and it echoes back as part of the website. Again, by show of hands here, we already knew. Okay, so one of the most notorious spots where we find it is in the search field. And the place we're playing around with it here is in this search parameter here. Can everybody see this more or less okay? I know it's kind of, okay. So that's the spot we're going to cross-site script here, okay? We're going to show just some basic HTML embedding. So we'll put a U tag in there. And at this point, we know that we can get HTML into the system and more, and also JavaScript in the system should we choose. So that's our vulnerable spot. What we're on here is a blog website that we purposely made vulnerable. We can actually go to the admin interface and sign in, but it's just a normal blog system. We tried our best to scrub the name from it, but I'm sure those familiar with this blog platform will know what it is. Come on, log in. That's unfortunate because it's running on localhost. Wow. Okay, we'll skip past that part for now. All right. So let's go back here, and we're going to start putting in some code. On this web server here, these are on the laptop in front of me is running multiple web servers. One, this site is running in the context of victim. This one will be our hacker, our adversary. And this is all the JavaScript exploit code that we'll be using. And the first one we'll be doing is we'll just do a basic browser spy. A lot of everybody does it, especially the banner providers out there. So we're going to show just how we're going to cross the domain barrier, script source in exploit code from an alternate domain, and it will execute within the same context of victim. So it's just basic stuff. Just shows the premise of some of the data we can get out of a web browser, user agent, cookie if we had one, screen width, plugins, all sorts of things. Just basic information that we can learn about the browser or learn about the platform which we're going to be executing attacks from. So when we're devising hacking the intranet, it's nice to know where the user has been, whether it's on the intranet, on the internet, and see where they've been so we can craft attacks particular from that user to those websites. So what we want to be able to do is steal their history. We want to know where they've been, okay? And an easy way to do that is, if you refer to the slides, is we use a hack using cascading style sheets. What we do in the browser here, and I'm going to bring this up, so we'll just go steal_history. Okay, and we'll bring up this screen. Contrast is really low, huh? Let me highlight it. Oh, that didn't work at all. Are the links showing up? More or less, okay. Now, what this hack does is it actually guesses at the history of a user's browser. What it does is in JavaScript space, it makes a bunch of links on the screen. All the top websites, banks and other things like that, MySpace, AOL, and even Black Hat. And what it does here from JavaScript space, it checks the color of the link and sees, sometimes, links will have purple or blue depending on if you've been there or not. So from JavaScript space, we check the color, okay? If it's purple, then we know you've been there. If it's blue, you haven't, okay? So now at this point, we know where you've been to, on different websites, and, we left out the adult websites, but, okay, so if we had bandwidth here, which we don't, they told me I had to use wireless for the demos, and I wasn't about to do that here. So somebody would have hacked me, and that would have been not good. Okay, so what happens in this demo, if we were to click on a link, go to Black Hat or something like that, and hit reload, it would show visited. So at this point, this is a very simple hack. The code's on the CD to show how to do this, but essentially, it's JavaScript accessing the color of the cascading style sheet so we know where you've been to, whether internally or externally. It also would be easy to make links for the internal IP address ranges after we find the internal IP address. All right, so we have that. Where's the slides? We know where. Okay, so let's see. The next slide, NATed IP address. Okay. So next one, we're going to start stealing the internal NATed IP addresses. So these are difficult to show without bandwidth here. But the code that we are doing is called I'm forgetting the name of here. It's called we're using the My Address applet. This is not our applet. This is something we borrow from Lars Kinderman. The URL is in there. What this applet is able to do is get the internal NATed IP address of the client. So when you surf a website behind your DSL router, you're usually surfing with your external IP. That external IP is easy to access because you're connecting with it. But when you access, but the internal IP address should be internal and private. Java, an applet, has access to this. And from Java space, we can actually move that data into JavaScript space. Now this is tough. It's tough to actually do on stage. Actually, impossible to do on stage without internet bandwidth. So I'm going to have to fake it a little bit. So I'm going to bring on the steel history. We're going to do the IP address here. We'll put that in there. Okay, what it's trying to do now is connect to an external machine that's hosting the applet. Can't do it here because we don't have bandwidth. But what it'll do is it'll give us back and redirect. The applet will grab the internal NATed IP address and redirect it and make it part of the URL, so we can get access to it in Java space. Again, I apologize for not having the bandwidth here. And then it'll throw it up in the URL, the external and the internal IP address. So we're just going to fake it here a little bit. So we're going to do external IP equals 206.0, because this is what it'll do when it's properly loaded. So that's the external. Don't you crash. Okay. No, it's not liking me at all. Okay, Firefox is supposed to be a stable browser. All right. It's not crashed yet. Somebody goes, Tom here was mentioning that this is the opposite of the Mac commercial. So
Jeremiah,
yeah.
Put it into the URL.
Yes.
As opposed to using like a live connect or something to try to access the Java public method.
I probably could have done it with, the question was, why don't you use Live Connect out of the applet? Because one, I didn't write the applet, so I only had access to what it gave me. So the methods that it gives you that we can show is that it allows you to redirect with the internal IP address and throw it up into the URL. And if it's in the URL, then we can access it from JavaScript space. So all right. So how many marketing people are going to want to get access to the history? One can only imagine. But it's very simple code. We can actually check out the history here and how easy the code is. These are the websites that I'm looking for here. It's just a big list I grabbed off Alexa, and it's about all the code you really need. So this is just displayment stuff. So the code here is this stuff here and this here, so maybe 50 lines. That's really all you need to steal history. And so this part here that we'll highlight here, that's the part that actually creates the classes for the cascading style sheets and the colors that you need. And this is the interesting line right here that actually checks the computed color from the cascading style sheet, so we can tell what color the link actually was. So all the magic you need is reduced down to really one line. All right, so let's go back to the IP address one and see if we can get some magic to happen. External IP 206.0.0, and internal IP equals, let's see, 192.168.1.2. Okay, so when it's on a live server, it'll look something like this. This is what it'll bring back. Your external IP, whatever happens to be, and your internal IP on the network. Again, using a Java applet to communicate back into JavaScript space. Now that we know where the user's been and their internal IP, we can then begin to go further into JavaScript port scanning. Okay, so we're going to load another piece of code here, set of the IP address. It's very, very similar. Okay, we'll load this up. And what I'm also going to show you is on this network here, 192.168.1.1, we have, it says first web application security talk, or web application security talk, where I'm bringing DSL routers to it. So it sounds kind of odd, but this is the router we're connecting to on this device here. And what I found interesting, and maybe not so interesting to a lot of you, that they put the default username and password, they actually wrote it on the bottom of this thing. So it's admin and password as our defaults. And if you look online, and on the presentations, all these devices have default passwords, usernames and passwords for the basic auth. So even if the user doesn't happen to be logged in when we attack them, normally nobody changes these things on the inside because it's on the inside. So we're going to type in use admin and password. And we access our router, okay? That's on the inside there. Now, if we want to port scan, we'll hit this port scan button. Okay, and we'll let it go. So it actually connected real quick, and what you notice here on the bottom, which you can't see directly, okay, notice the status bar here. The JavaScript code is actually forcing my browser to connect to internal IP addresses based upon my internal IP address. It's actually scanning the class C based upon the internal IP address that the Java applet found. How this mechanism works is that from JavaScript space, we create script source equals, you know, the little HTML tags where you can script source in JavaScript like we've been doing here, from all those IPs, from all the internal IPs. What happens is when you go script source equals an IP that happens to have a web server, what does it do? It responds with an HTML page. The HTML page runs into the JavaScript interpreter and errors, okay? And the error we can actually capture from JavaScript space. So if it errors, we know there's a web server there and it was responding with some data because it caused an error. If it didn't respond, we know there's no web server there and we can move on. So that's the mechanism is it's clever. It's not terribly difficult once you understand how it works. So in about maybe 30 to 45 seconds, it will have scanned a class C. And we can also do to make this hack more invisible is we can clear out the status bar also. So at this point, it's almost done port scanning, and it's found 2 web servers. If you view the slides, you'll see we ran it on our internal range and other internal ranges, and it'll find a whole bunch of web servers there. So now we know where the user's been to. We know their browser type. We know their internal IP address, and we know the web servers they can get access to. And they could be printers, DSL routers, what have you. Okay. So in the DSL router here. One of the areas that we'll show you, this is just the DSL router web interface on 1.1. Okay, and one of the interesting areas that we thought we'd go after is the port forwarding. Where was it? It's a WAN setup. Okay, is the DMZ setting here. So the DMZ setting here, I'll just describe it how they put it. Specifying the default DMZ server allows you to set up a computer or server that is available to anyone on the internet for services that you haven't defined. There are security issues with doing this, so only do this if you're willing to risk open access. Okay, so I said sure. All right, so to make this easier to see, we'll open this frame in a new window, in a new tab. Okay, now if we were to change this, we can change this to anything. We'll say 22, and we hit apply. Okay, this will take a moment here, and it'll update it to 22. But the thing is, what you'll notice here is that the URL hasn't changed because the request sent in as a post body. Now we can actually force the browser to send off-domain requests, the so-called cross-site request forgery requests using post, but it's much easier and much more visible for the audience to do it over GET. So this browser toolbar here, if you're not familiar with it, if you're a web hacker or want to get interested in this, you're interested in this space, this is the web developer toolbar that it's a Firefox extension, allows you to do a whole bunch of cool stuff. One of the things we can do is in the forms here is convert post to GET. Okay, and you'll see what happens here. We'll change that to 111, and we'll hit apply. And watch what happens in the URL here. The request that we sent that is normally in the post data has now been pushed to the URL, and it's easier to see and modify. So this is what URL we want to send the user to, and you can see the 111 in here. Okay, so we're going to save this, and we'll toss it in a little text file here. Okay, make sure it wraps. Okay, so now if we were to change this to 44, for instance. Toss it back in here. You can see, it's very simple. Okay, and it'll update and go to 44. The problem is, when we cross-site script a user, when we get them in contact with our malware, chances are they're not going to be logged into their DSL router. They're not going to be basic auth, so they're not going to be able to directly access it. So we're going to have to help them. Okay, help them access their own DSL router or whatever it happens to be. this finish. Okay, so what we're going to do here is we're going to clear the private data, we're going to clear the basic auth credentials, okay, and we're going to hit reload. So now I've cleared the credentials, my browser doesn't know how to authenticate to this anymore because it doesn't have the password, so we hit cancel. So one trick we can do is if we know what the device is, we can make an educated guess of what the DSL router is. More or less the passwords are admin password or no username password as a password if you have a DSL router like mine. So we're going to go admin password, that password. You can actually put the basic auth credentials before the host, little URL trick that Firefox supports. Then we put this up there and hit, we'll change this to 55. And it gives you this little alert here. What's interesting here is that when we do this another way, when we force an image source to this, we'll get to this in a second, it pops up an alert, but only in this context. There's other contexts where it won't pop up this alert. So we help the user log in, and it makes the update. Okay, so now we know the request that we want to have our users make to update their DMZ. Well, I want to make it so they get DMZ, so I can attack them directly. Okay. So we're going to bring up another screen here, the controller. Okay, and this controller is actually another web server running that's accessing a backend database on this machine. Okay, I'll get to why in a second. Okay, the next code that we'll run is the zombie. Okay, zombie.js. This is actually lots and lots of JavaScript code. Okay. Lots and lots of JavaScript code that does all sorts of stuff. Keystroke recording, history stealing, cookie stealing. And what it does is right when you load this code, right when the user comes in contact with this code, it does all the hacks that you've seen so far and pushes all the information off domain where it could be accessed. So we're going to hit enter on this. Is it zombie in here? Good. Okay. Now, let's see. What you'll see is here, immediately upon loading of this exploit, the browser starts port scanning the internal range, okay, and starts pushing a bunch of data off domain. I can probably show you the web server logs so you can see what it's doing. See, what it's doing here, this is the tailed web server log, so it's actually pushing a bunch of data off domain. You see these bits here? Pushing plugin information, cookie information, whole bunch of stuff. Let me see if I can actually, I'll do that later. Okay, so also what you're seeing here, you see the red border around it? What's happening here is that we've erased the web page, the initial web page, and we've overlaid a full screen iframe over the existing web page, okay? And so we can see it, we put a red border around it. So what happens here is that anywhere the user clicks, we're still in the thread of control because the exploit code is running running behind. So if we click, they're still in the thread of control, okay? That makes sense? And all the HTML gets pushed, and everything they do gets pushed off domain. So if we were to reload this page, we're actually tracking the user, okay? And this page, we're pulling the data out of the database that has been pushed off domain by the cross-site scripting exploit. We've sessioned them so we can uniquely identify them. We have their external IP. We have their internal IP. We have their user agent, any keystrokes they add. We can have their screen resolution, their history, the web servers they can access, and their plugins. And then we can start controlling them remotely. So I'm going to actually move this page, and I'm going to make a new window. So actually you can see this going on. You can probably dual screen this a little bit. Okay, so from this little pull-down window, I made it easy for myself to mess with the user a little bit. Okay, so let's say I want to redirect the user. So now they're surfing the page, they're having a good time, and we want to redirect the user. So let's say I want to make them go to the admin screen and log in. Okay, what this does, it references that iframe and says, why don't you go to the blog site and go log in. Okay, so notice in the background, see them redirect? We can actually control where they go. Okay, could be the administration interface, could be any website, their online bank, doesn't matter. Okay, now we're going to log in here. Nobody know my password. And hit login. Don't want to confirm this, don't care. And they will log in, hopefully. I'm sorry? Empty. Is it? should go directly. I only tested this like 100 times. In any event, we'll hit reload here and see where the user's at. So also, you saw we typed in admin. So this code has actually a built-in keystroke recorder, and that every keystroke that you fire will actually get sent off domain. You'll see this happen here if you watch the screen just a little bit. So we'll hit D and see the keystroke right there. As soon as you hit a button, that keystroke goes off domain and we captured it. Neat, huh? Okay, so now let's oh, so there we go. Finally decided to log in. Okay. Now let's see here. Where were we? Where was the window? Okay, so what else could we control the user to do? Well, let's redirect them back to the main blog webpage, and we'll do some text substitution and things like that. Let's see here. Okay, hold that. Okay, so we'll send them right back to the victim. Send them back. Okay. So, in the background, we've sent them back to their blog webpage. Now, let's say we're cross-site scripting, a major news site or some site that really cares about their brand, a credit card company or something like that, and we want to start messing with the content on the page. With this bit of code, with JavaScript, we have access to just about every piece of data on the page. I think all the data on the page. And let's say we want to change this myspace.com to whitehatsec.com, because we can. We hit send, and almost instantly, it just changes it right to whitehatsec. We just send them a command, and they're actually reading a new article, and we can change any aspect of the article we want, and all of a sudden, it's there. So bear in mind here that we're on the real domain name. We haven't switched off domain name. They're still on victim. They still be on bank.com or ecommerce.com, whatever site they happen to be on. We haven't changed where they actually are. So if they're over SSL, fine. But it's not a lookalike domain name. It's the real domain name. So let's try another one. Let's say we want to make the iframe invisible. No problem. Now they can't see us at all. Okay. Now just be clicking around with no one's the wiser. Let's make it visible again. And let's say we want to mess with their head a little bit. And we want to start sending them alerts and talk to them. Okay. Okay. Start sending them commands and do weird things and embed flash games on their screen or whatever. Okay. So we have alerts. Now we can overlay images, but on our local office network here, we were actually able to send printer test page requests from the user's browser. So you fire these commands, or you make them go to a web page, and all of a sudden our printer starts firing off test pages automatically. So here's one thing we can do. So now at this point here, we know where the user's been. We have them in our threaded control. We have their cookies. We can make them authenticated requests anywhere we want. We can port scan the internal range. So let's start hacking internal network devices here. Okay, so we know the router is probably on 1.1. Okay, so let's make a new iframe there. Okay, so now we've sent them to the place where we want to go. That's an example that we can force them to go to this particular page, but we don't want them to. This is not the request we want to make. So I'm going to hit reload here a little bit to get a new session. And it's actually going to port scan me again, so I probably shouldn't have hit that button. Okay, so let's go down here, the other session. Let me delete the other session. What session am I on? 5747. So I told you there's a back-end database. So we'll delete the one we had before. Okay. Now, we're going to take the URL that we built before, okay, and this is where we're going to redirect them to, okay, so we can make it visible. So for instance, let's go back to see if we're still not authenticated. So we are authenticated here at this point. We don't want to be, so to make it more real. Okay, so let's reload this. They're not. Cancel. Okay, good. Can't get to it. We're unauthorized. So let's send them to the DMZ, and we'll bring them to that URL that we made. Okay, that's where we want them to go to. So, praying that this works. Okay, we'll send them a command. Let's, before we send this, let's actually copy this real quick. Make sure we can send them commands at all. There we go, okay. Now, let's send them this command. We'll go send them here, and we'll see what happens. Come on. Nothing? I got an alert again? Huh. Let's go back to here. Let's change that URL again. Okay. Send. There we go. Notice no alert. Automatically updates their DMZ to them. Okay, we'll wait for this to finish and we'll go back and check the router directly. So again, this can all happen invisibly in the background really quick. You hit a MySpace page, a Yahoo Mail page, any page with JavaScript, probably the sites that you trust to have people submitting data. You hit the website, it steals your history, it port scans your network, and then decides to update your DSL router DMZ in you so the hacker can attack you directly. So this is what we have to look forward to out here. Okay, so let's go back here, and we can see that we're now automatically authenticated, and now we can hack DSL routers. We can hack anything internally with an IP address. So what's going to happen now? I think now that people have shown that we can start hacking internal DMZs, we're going to see lots of research into devices like these to get, how do we fingerprint them? How do we, I probably should have covered that part. How do we fingerprint them? How do we hack them? And the request. So we're using all sorts of hacks here to make that possible. Any questions at this point? Everybody scared enough yet? Yes. Can we dump the username and passwords out of the browser? Oh, you mean wherever? To tell you the truth, I don't know. I've not tried. So, so the question was, can we dump their existing username and passwords out of the browser? Maybe. I don't know. Maybe it depends on the browser. So, another question over here? Yes. Yeah. Yes and no. So, for instance, let's say the yes part. Let's say I cross-site scripted you, and you're currently logged into the firewall. I'm just going to leverage your credentials because I'm forcing your browser to do it. So I'll be able to use your credentials to start attacking the device. But that scenario is going to be somewhat rare. Okay. So, for instance, if I don't know the device, maybe the firewall has a password, or maybe we can brute force it, or we don't know the password. Or let's say it has a cross-site scripting vulnerability in that device, and we've seen a ton of cross-site scripting vulnerabilities in internal devices. We can start attacking it directly using your browser. So it's kind of a yes or no question. Right. Well, you're absolutely right. So in that particular hack, what we wanted to show is that an external person could change the DMZ so we could hack the machine directly. At home, that might be a problem. Depending on your router or your firewall, that might be a problem. If we just want to mess with your printers on your network. So this is just a versatile hack. But basically what I'm going to be describing, what I think is going on here is that cross-site scripting has become the new buffer overflow, and JavaScript malware is the new shellcode. And we're going to see lots and lots of stuff. So it's not just one thing, it's versatile. It's just, what do you want to hack today kind of thing. Yes? Good question. We'll get to it in a minute. Let me just pass through the slides, and we'll answer that question in a second. Yes. Correct. So the question was, it's only vulnerable, let's say, or attackable when your browser's open? The answer is yes. Since there's no exploit code on the system, that's a good thing and a bad thing. If I make you do something illegal, go to some illegal website or hack another machine, if you had a Trojan on your machine, you can claim, well, the Trojan maybe do it or something like that. But if you closed your browser, the JavaScript code is gone. No one's going to see it. No one's going to look for it. It's literally gone. Yes? You could. some, you can configure it so we can't, but you can. Sometimes you can, sometimes you can't. But, who's looking there anyway? I just happen to put hacker there. So, I think JavaScript malware is the new shellcode. So let me finish up the slides here. We'll get to some solutions here in a second, since it's probably a good thing. So let's swap back out. I'll get a second. So one thing I didn't mention, I'll cover real quickly, is fingerprinting. There's all sorts of ways to fingerprint internal devices using the browser while blind. One method that has, that was created was fingerprinting by unique URL. So what you do here is you go image source equals where the web server is, and a unique image URL on the device, whether it's a printer, router, firewall, Apache web server, IIS web server. And what happens is you put an on-air event handler onto the end of the image, and if the on-air event handler doesn't fire, meaning the image was there, you know what the web server is. So you got a bit of uniqueness in the image URL, and now you can figure out what the device is, so you can start tailoring your attacks. This is just one way to fingerprint the web servers while blind. You could do other methods such as unique JavaScript objects, but I won't be covering all that here, in CSS objects. But it's a very simple way. So one way we found was using the PHP Easter eggs, that you could figure out what version of PHP a system's running by using their Easter egg URLs there. Any questions there? I'll cover this quickly, and we'll get to the solution since we seem to be running out of time. Okay. So we got all that part. I'll skip all this stuff here. You can go back to the slides if you want and see more of that stuff. Let's see. Let's start here. Okay, so other dirty tricks we can do using these sorts of methods. We can do black hat search engine optimization stuff. We can boost our rankings in search engines because we can put links on other people's websites. We can force the user to click on banners. We can do distributed denial of service attacks. We'll get to some of the worm stuff, but once you can leverage a million browsers, you can send them to any place you want, potentially DOS the website. You can force a user to download illegal content. I mean, you have control over their browser to do anything you want. You can vote tampering, you can de-anonymize people, all sorts of stuff. Okay, so let's get to solutions, and I'll let TC take over. Want to go for it?
Vulnerabilities that Jeremiah is talking about in examples, they're widespread. First one, cross-site scripting. A lot of the talks today are going to be talking about this issue. It's, as the data says, it tops the web hacking incident database. Security Focus found over 1,400 issues. White Hat, we found over 1,500 issues. The statistics that we see are that 8 out of 10 customer websites have cross-site scripting issues. It's common, it's out there, we know it's out there. The issue is that now, these days, we're seeing it actually be exploited. We're reading various news examples about Yahoo, MySpace, PayPal. These vulnerabilities are being exploited. People are taking advantage of them, and so it's become a more serious issue. It needs to be addressed. What this example shows, though, is it increases the scope of what we're able to do with these cross-site scripting attacks. Now, there's a second attack vector that we've used in these attacks, and that's the cross-site request forgery that Jeremiah talked about briefly. The gist of cross-site request forgery is that the website trusts the user when a request comes from the user. So if we take the DSL router example, the DSL router says, oh, okay, you're sending me a request to update your password, or you're sending me a request to change the settings. Cool, I'll do it. The problem is that another website can force the user to make that request. In the example that we showed, we had some cross-site scripting code, we sent it to the victim, they made that request, they updated their DSL router. This works for just about every web application or device out there that you attach to a network. If you're on MySpace and if someone sends you a link that's the delete all your friends link, you'll delete all your friends. If you're on Yahoo Mail and someone sends you the forward all your email to someone else link, you'll forward all your email. It trusts you.
If you're on your web bank and I say, wire me all your money, your browser will do it.
Yeah, that's what's so scary. And so the issue here is that we don't have any hard statistics about how prevalent it is because every website does it. Websites don't look at that information. They trust it.
So some cross-site scripting hacks in the news that we saw. One was Dig, the popular one of the social networking websites where you post stories and people, click on it and dig the story. If you were to view this particular blog page, what it would force your browser to do is automatically dig that story. So as soon as you hit the site, if you're logged in today, it would automatically dig the story and force your browser to do it. So that was one example out there. Another one was a vulnerability that we disclosed to Google, where if you viewed one of the websites that we made, it would force your browser to, if you were logged into Gmail, to download and show all your email addresses, your contact list at a Gmail. Both of these have subsequently been fixed. But the point is, as soon as you hit a website, that website can really force your browser to make any request that it wants to any website. So that's where cross-site request forgery gets bad. It gets really bad if you happen to be logged into that website.
Cross-site scripting, this has been an exciting year if you want to see what these attacks can do. Almost a year ago, in fact, Sammy created the first large-scale cross-site scripting work on a famous website called MySpace. Probably everyone here has heard of MySpace, one of the most popular social networking sites on the web. And so what Sammy did was he wanted to become popular. So he updated his profile, and he tried to find a way to fit some cross-site scripting code into his profile, so that when someone viewed his profile, he'd be able to run JavaScript, right? MySpace already had some controls in place to filter out his cross-site scripting attacks, but he spent enough time to get past the filters while he was eating burritos and hanging out in the coffee bar. What he did is he put in some cross-site scripting code that got past the filters, and he made it so that, first of all, anyone that viewed his profile would automatically update their profile with the same code. Then he did some fun things, like he, had them add him to their friends list because he wants to be popular. That's the goal. And he also made them update their hero section to say, and most of all, Sammy is my hero. Pretty exciting, some of the techniques that he used. He actually, we talk about Ajax. Well, MySpace uses some one-time passes so that, for instance, if you're going to submit a post to update your user profile, there's this page in the middle where it has a one-time pass. That needs to accompany the post in order to work. He would actually go and retrieve that page, take out that data, and then make another request, including that one-time pass.
So we also had some recent examples on Yahoo Mail, same sort of thing, where you got an email attachment laced with some JavaScript malware. You open the email attachment, it reads your Yahoo contact list, and then sends a copy of that message to everybody in your contact list that's on Yahoo. And that's how that particular worm spread. We don't know how widespread it got, but these are some examples of the things on how JavaScript malware can get out there to its system and hit lots and lots of users.
As far as impact, the Sammy MySpace example, it's snowball. Someone viewed his profile, and they'd get infected with worm. If someone viewed that profile, they'd get infected too. In 24 hours, he had over 1 million people trying to request him on their friends list. MySpace, in turn, had to shut down for 24 hours in order to fix the issue. During this time, they're not generating ad revenue, people aren't logging in. This is just the beginning.
So, how do we protect ourselves? So there's, two ways to go about it. One is protecting the server, one is protecting the client. So what solutions do we have here? So let's take a look. Go for it.
There are a lot of good solutions out there for users, but the issue is, what happens if you can't trust that the server has actually been fixed? It hasn't been patched, they haven't addressed those concerns. What can you do? Patching and antivirus. Right now, today, there aren't solutions to let you run antivirus software that'll identify this JavaScript malware as it's being rendered in your browser and say, hey, that's actually a virus or a worm. The other example, corporate web surfing filters. This would work if the issue was that you're going to bad sites, questionable sites that, you probably shouldn't go to and they can have bad code. The issue here, though, is that we're going to trusted sites. We're going to Yahoo Mail, we're going to MySpace, we're going to AOL. And so most likely, the corporate web filter isn't going to stop you from going to Yahoo Mail or New York Times.
So what these solutions are designed to do, like SSL, two-factor auth, or staying away from questionable websites, is they're designed to protect you from, bad websites, the websites you're not supposed to go to that might be dangerous. The problem with cross-site scripting, the JavaScript malware stuff, is we think you're most likely going to get infected in the websites you trust, like Yahoo, like MySpace, like the major websites out there. So these solutions are good for other areas, but for this, they're just simply not going to work. So what are the better solutions we have out there?
Well, as a user, if you get an email, you look at the link. It looks suspicious. If it's really long, it looks like there's JavaScript code in it or something, don't click on it, right? But the problem with this method is that the attacker could encode the information in the URL, so you can't really recognize what's going on. Or they could use services like tinyurl.com, so that you no longer really know what's going on with that link.
Another method is, like was mentioned, we can use like something called the NoScript Firefox extension, which gives you control over JavaScript on which, what sites can have JavaScript in them, gives some users some control. The problem with NoScript is it's very good for limiting sites, dangerous sites from that you don't need JavaScript. But the problem with NoScript on this site is if you're surfing, again, MySpace or one of the trusted websites, you're going to turn JavaScript on these systems because you're going to want to use these sites and they depend on it. So NoScript we don't think it's going to help you much here, and the same is true for the Netcraft toolbar. These are all designed to spot out the bad websites, but not the good websites doing bad things. So, perhaps one of the solutions you can do is when in doubt, disable JavaScript, Java, ActiveX, but as TC says,
Website's not going to work.
Sorry.
But as far as Netcraft toolbar, we have found that the Netcraft toolbar actually checks in some places for cross-site scripting that's going on in the URL bar. So for instance, if it's a cross-site scripting attack where, for instance, they give you a link, you click on it, you go to that page, it'll be in the toolbar, and Netcraft has some features in there to identify it. But it doesn't always work. And the other issue is that it won't work for persistent cross-site scripting. That's where someone's put code in the database, for instance, when Sammy put code in his profile. And then he sends you a valid link to his profile, or you just stumble over it, and then the attack proceeds. That cross-site scripting code is never in the URL bar of your browser. It's actually already in the page.
So we're going to start speeding up a little bit here because we're running out of time. But the point is, if those client-side security solutions look weak, it's because they are. We've been recommending for a while that the Mozilla guys, Microsoft guys, Opera development teams need to start doing more. There have been some suggested remediations to this, but to the best of my knowledge, no one's working on helping more in this particular area. So more research needs to be done in this area. We can claim all we want that the fix is on the server. It is there too, but I as a user don't want to be dependent on the security of a particular website to protect me. That's the point we're trying to make. So easy ways, fixing cross-site scripting is really easy. Yeah. So
99% of cross-site scripting can be fixed by adding one line or 2 lines of code. What you need to do is at the server level, if you can, for all your applications, filter the input, sanitize the input. Don't trust the user data.
And we see people doing this particular solution in a lot of places, but it has to be done more diligently on lots of more areas of input. And if you want to protect against yourself from cross-site request forgeries, research session tokens, CAPTCHAs, and we used to think refers work, but refers aren't going to help cross-site request forgery anymore, so we had to cross that one out just recently. So the best advice we can give the world right now to fix this solution is really on the server. Find and fix the cross-site scripting vulnerabilities before the bad guys do. When absolutely nothing can go wrong with your website, there are good web application firewalls out there, such as Mod Security. You want to get the defense in depth going, and also it might be time to start hardening the intranet website, especially devices that are running these web servers. So a couple of helpful tips there, and we felt the need to plug books, from one of our employees, Hackers Challenge 3, and I wrote the forward for Hacking Exposed 2nd Edition and the Preventing Web Attacks with Apache. So if you want to know more about WebAppSec, these are the 3 of the best books out there. And thank you very much for coming. I think we ended the time. So.